Okay, today I want to talk about why the quadratic equation works. Now this is going to be a supplemental video to section 9.2, I think it was, yeah, 9.2. So you're not going to need to actually do this at any time on any tests or quizzes, but if you understand this, then that means that you understand it solidly. You got it good, got it down. So I'm going to go ahead and explain it, and hopefully it'll make sense to you. So let's just do one quick brief review. So by quadratic equation we mean that ax plus bx, ax squared plus bx plus c equals 0 has the solution of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this, for x, is going to give us the solution for this quadratic equation. So, before I actually go into proving the quadratic equation, I want to show you something called completing the square. So, completing the square. Now, this actually is something that's done in most Algebra 2 classes, but we're skipping it for ours. You're probably going to be doing it in the next one, though. Even so, I want to go ahead and show it to you here. So, remember that if we have x plus j squared is going to be equal to x squared plus 2jx plus j squared. I don't know why I chose j. I wrote this last night, and it seems kind of strange to use j now, but I guess it works. So, x plus j squared. So you have the first term is squared, then the last term is squared, then you have 2 times the first term times the last term. So you have 2jx. Okay, so now for the next, let's rewrite this, but instead of using j, let's use j divided by 2. So x plus j divided by 2 quantity squared is going to be equal to, here, let's make that, do this a little bit differently. There, okay, that makes it a little bit easier to see, I think. So, all we would do is we would replace, just like we'd have the same thing up here, but we would replace j with j over 2. So that means we're going to have x squared plus 2. Whoops, that's not j. I mean, that's not 2. That's j. 2 times j over 2. And let's go ahead and put that in parentheses. Okay, 2 times j over 2 times x plus, let's see, j over 2 squared. Okay, so let's go over this one more time. All I did, I'm going to go ahead and clear that stuff off, just so you can see it more easily. All I did was I have the same thing here that I do here, except I replaced j with j over 2. So that means I have j over 2 here and j over 2 here. Now let's go ahead and simplify this just a little bit. I'm going to keep this the way it is. I'm going to keep j as j over 2 squared. I could simplify it by making it j squared over 4, but I'm going to go ahead and keep it this way because I wanted to show something. And this term will stay the same, it's just x squared. But for this one, notice that I can cancel the 2's, and I will get that okay, so this is going to take a little while to type out. Okay, so x plus j over 2 quantity squared is equal to x squared plus jx plus oops, not j squared. I mistyped that. So we have Okay, so that means that since these 2's cancel out, you get x squared plus jx plus j over 2 squared. So that means that. So let's take a look at a different situation. What if we're given just this, x squared plus jx? But let's go on. I'm going to clear this off, and let's go on to what if we're given. What if we're given, let's call it x squared plus kx. So what we'll find is we can use this property. Oops, that's not right. We can use this whole thing, the concept behind this, to rewrite this as a square. I mean, well, you know what? I'm just going to show you, and hopefully you will understand what I'm talking about. But we're going to be using this concept to do something special with this. Do something to make it a little bit manageable for certain problems. So we have x squared plus kx. Okay, so let's go ahead and add something to that. X squared plus kx. Now let's add let's scroll down a little bit. I want to keep this stuff right here. Now let's add k over 2 quantity squared. Okay, but notice that once I add something, I change the value of it. So to change that, I'm going to have to subtract off the same thing. So that means we're going to add k over 2 quantity squared minus k over 2 quantity squared. So and the reason why is because this is like adding 4 and then subtracting 4. That way they could cancel out. But we're putting it in there because that way we have something that we recognize here. See, we have x squared plus kx plus k over 2 quantity squared. That's exactly like this, except you have k instead of j. So that means on the next line we can rewrite this as let's see, we have x plus k over 2, x plus k over 2 quantity squared minus k over 2 quantity squared. Okay, so all I did was, since this is going to be equal, since this is going to be equal to this, and all we did here was replace the j with k, that means I can replace this entire thing with this. And of course then we still have the minus k over 2 squared. What we did here is we completed the square. We had this is just almost a square, but it's not quite because you need a term that'll complete it. We need a plus something. But then of course once we add that something we have to subtract it too, because we're not changing the actual value of the expression. And that's what this is here. We added it and then we subtracted it off again. But now this turned out to be a perfect square, so we can rewrite it as a perfect square. And you can, any problem that involves the quadratic equation can actually be solved using a perfect square. In fact, the quadratic formula, the proof of the quadratic formula comes from completing the square, which is what we're going to do next. Now, using the quadratic formula is much easier than completing the square every single time. In effect, you're actually doing the same thing. When you use the quadratic formula, you are completing the square. But it's just a lot easier to think of it in terms of the quadratic formula. For very, very once you see the proof, you'll see why it's the same thing and why it's easier to use the quadratic formula. Okay, so let's proof proof of the quadratic formula, which will involve completing the square. Okay, so first let's start out with ax squared plus bx plus c equals 0. Now, we already know that the quadratic formula will work, but right now we don't know that. We're presupposing that we don't know what this is going to be, so we're going to try to figure it out. So the first thing I want to do is, well, I'm going to subtract c from both sides. So that means I'm going to have ax squared plus bx equals negative c. And this is the same thing. All I did was I subtracted c from both sides. And now I've got this ax squared. Well, that's difficult to work with, so I'm going to go ahead, and what I'm going to do is I'm going to factor out an a. Now that may sound strange since there's not an a in this term, but this is what I'm going to do. I'm going to rewrite this as ax squared plus b over a x. Okay, so what I'm doing, okay, first of all, let's go ahead and make that equals negative c. Okay, now this is the same thing as this whole thing here, because if I distribute this a will go to x squared to make ax squared. This a will go to b over ax, will cancel with the a to make b times x. Now I'm going to go ahead and do that over here. So we have, all I'm doing is I'm going to distribute this a. So we'll have ax squared plus a times b over a x. So this a cancels with this a, and you'll get ax squared plus b over x. Not over, sorry, times x. So that means that a times x squared plus b over ax is equal to ax squared plus bx. Okay, now I'm going to go ahead and clear that off. And so now we have something that is almost a perfect square. So I'm going to go ahead, I want to get this a over here too because it's in the way. So this is going to be equal to x squared plus b over a times x equals negative c over a. Okay, so all I did here was I divided both sides of the equation by a. So divide this side by a, the a's cancel. Divide this side by a, and nothing cancels, so you get negative c over a. And so now I have on this side, I have almost a perfect square. So let's scroll up a little bit to once we had almost a perfect square. Remember, what if we're given x squared plus kx? So if we're given almost a perfect square, we take the middle term, half it, then square it, then we add it on and subtract it off. So, you know what? Whenever I described this, I should have said that before. When we're completing the square, you take the second term that's going to be the middle term in your perfect square, half it, and then square the entire thing. So that means if we have x squared plus, okay, let's say 4. No, let's make it something different than that. Let's make it 6. 6x. So we want to complete the square of x squared plus 6x. So we want to take the half of this, so x squared plus 6x, take half of it, 6 divided by 2, and then square it. Okay, I'm running out of room here. But then once we square it, we want to subtract it off again. So, I'm sorry, once we do that, we want to subtract it off again. 6 halves. Okay, I've kind of got some room. So, x squared plus 6x plus... Okay, so that's going to be 6 divided by 2, which is 3, plus 9. And of course, this is going to be the same thing. Now, a lot of people, whenever they do this, they immediately instinctively think, oh, I have a plus 9 and a minus 9. I want to go ahead and cancel those out. Well, we don't want to cancel those out because that'll just get us back to where we were before. You're only canceling whenever you've done what you need to do, and now you need to get it in the form of an answer. But we haven't done what we needed to do yet. So now what we have here, these first three terms is a perfect square. So we have x squared plus 3 quantity squared minus 9. So we took the middle term, what's going to be the middle term, actually it's the coefficient for the second term, and then we halved it and then squared it, and then we put that on the end and then we subtracted it off again. So let's go ahead and clear that off. And now we're going to do the same thing here. We're going to half this and then square it. So we have x squared plus b over ax. Now I'm going to take half of that, b over 2a, excuse me, and then I'm going to square it. And I'm going to do a little bit more explanation of that in just a second. So half of b over a, so that means what I'm going to be doing is I'm going to be doing b over a. Half of that is going to be all over 2. Well, let's think of it this way. This is the same thing as b over a divided by 2, and 2 is the same thing as 2 over 1. So that means this is the same thing as b over a multiplied, whoa, that is not multiplied, my hand slipped, multiplied by 1 over 2. Then you combine these two to get b over 2a. So, sorry to cough right in the microphone. So that means that half of b over a is going to be b over 2a. And then, of course, we square it again. So I'm going to go ahead and clear that off. And, of course, now that we've added this, we don't want to actually change the value of anything, so we need to subtract it off again. So we have minus the same thing equals negative c over a. Now, this is, I mean, I can keep this here if I wanted to right now, but there's really no point for it. So I'm going to go ahead and move it to the right side. Wait, did I do this right? Just give me 1 second. Sorry. It's easy to mix this stuff up sometimes. Oh, yeah, I did. Okay, so now I'm going to go ahead and move this to the right side by adding b over 2a quantity squared to both sides, and then doing the same thing over here, b over 2a quantity squared. I think my mouse writing is actually getting slowly better. I'm not positive, but possibly. So that means we're going to have x squared plus b over a times x. You know what? I'm going to go ahead and put parentheses around the b over a just because that might be easier to distinguish it. So plus b over 2a quantity squared to a b over 2a quantity squared equals negative c over a plus b squared over, okay, yeah, sorry, b squared. I'm going to go ahead and while I'm at it, I'm going to distribute this this squared. So we're going to have b squared over 2a squared, which will be 4a squared. Okay, so I skipped a few steps at once, so I'm going to go ahead and go through it up here. So I added b over 2a squared to both sides, but b over 2a quantity squared, well, this b over 2a quantity squared is equal to b squared over 2a squared. I don't remember which rule of exponents that was, but it was I think they called it the quotient rule. That didn't look much like a 2. Okay, so it is called the quotient rule or something, where this 2 distributes both to the b and to the 2a. So, and then this 2 will distribute to both the 2a and the a. So that means you get, so just like the 2 goes to the b and goes to the 2a, this 2 will go to the 2a and to the a. So that means we'll get b squared over 4a squared. Okay, now I've got this mess of stuff over here, but I'm going to put off doing anything with that for just a little bit. First, I want to deal with this right here. Now, I have a fraction plus a fraction. I can go ahead and do something with that. I can go ahead and find like terms, like denominators, and add them together. So, I'm going to go ahead and clear off what I have up here. And this a, so both denominators have 1a, but this denominator has 2 a's. So, and this also has a 4. So that means the common, okay, let me start that over from the beginning. So there is at most 2 a's, because you have here you have 1a, but here you have 2 a's. You have a squared, which means that the greater of those two is going to be a squared. So you have at most 2 a's, and you have at most 1/4. So that's a 1, not an L, and that's not 14. That is 1/4. So let's rewrite that out separately. At most 1/4. Okay, I take back what I said about my mouse writing getting better. It's getting worse. So we have at most 2 a's and at most 1/4. We have at most 1/4 because we have 1 here, but we don't have any here. The greater between 1 and 0 is 1. So we have at most 2 a's and at most 1/4. So that means our lowest common denominator is going to be 1/4, and 2 a's. So what is, I'm going to write that a little bit to the side here. LCD, because I want to scroll down, equals 4a squared. Hopefully that's not too small, you can see it. So I'm going to go ahead and erase this stuff up here. Wow, that takes a long time to erase. I would clear the whole thing off, but I just wrote that down there. So okay, so now I want to scroll down. A lot of other stuff to erase. Okay, so that means what is lacking from this fraction that it can be added to this fraction? It's lacking a 4 and another a. So we can rewrite this. I'm just going to copy down the left side. Okay, so we can rewrite this C. The thing that it's lacking from the LCD is exactly 1/4 and exactly 1a. So we can multiply top and bottom by 4 and a. So that means we have negative C over a times 4a over 4a. So we're multiplying the top and bottom, not top and bottom of the of this fraction by 4a. And then, of course, we still have this fraction on the right side, plus b squared over 4a squared. Okay, so now we want to go ahead and multiply these two together. So we'll have, and on the bottom we'll have, I'm sorry, on the left we'll have we have the same thing, because we haven't even touched the left side, equals, and then we get negative 4ac. You may already be beginning to see exactly where this stuff comes from, because you see 4ac, oh, well, that's actually in the quadratic equation. There's a minus 4ac in there. Quadratic formula, excuse me. I often say quadratic equation when what I really mean is quadratic formula, because the quadratic equation is just ax squared plus bx plus c equals 0. The quadratic formula is the x equals negative b blah blah blah. Okay, so anyway, we have a negative 4ac over 4a squared plus b squared over 4ac. Well, now we have like denominators, so we can go ahead and add these two fractions. So I just cleared that off. Hope that's not too soon. But again, I'm going to keep the left side untouched. Equals fraction of negative 4ac plus b squared over 4a quantity squared. Or alternatively, I want to just rearrange this so we have, and I'm not going to do this on the second line. I'm just going to do it here. Fraction of b squared minus 4ac all over 4a squared. Okay, so do we see something that we recognize yet? Well, b squared minus 4ac, it's the discriminant. So that means that we're headed in the right direction. We're seeing something familiar from the quadratic equation, quadratic formula, excuse me. It's b squared minus 4ac. That's the discriminant of the quadratic formula. Okay, so now that we've got that down, let's deal with this. So this is, what we have here is a square term, and then okay, sorry, let me start this over. This is a square term. This is a square term. Now let's take 2 times x times b over 2a. All I did was this is the square root of the first term. This is the square root of the last term. And now let's go ahead and multiply across what we can. So we have 2x. Well, this 2 next to the x is going to cancel with this 2 in the denominator for the b over 2a. So that means this is going to equal x times b over a. You know what? I don't remember why I put that. I did not mean to do that in parentheses. I just realized that all that time ago, whenever I said I want to put that in parentheses so it's easier to see, what I meant to actually do was this. I did not mean to. I did not do it the way I meant to do it. Okay, so sorry about that. So b over a times x, not b over a x in parentheses. That would not make anything easier to see. This just makes it a little bit easier to see. So x times b over a, or b over a times x. So now, since 2 times the square root of the first term times the square root of the last term equals the middle term, what we have is a perfect square, which makes sense because remember that we got this by completing the square. So that means that we can rewrite this as x, okay, I'm going to just say x plus b over 2a quantity squared. X plus b over 2a quantity squared. Okay, so now, of course, the right side, of course, is still the same, so let's copy that down. Equals b squared minus 4ac all over 4a squared. Okay, so now we have x plus b over 2a quantity squared equals b squared minus 4ac all over 4a squared. But we have this square here. Remember from, I don't remember the square root property, I don't remember what the section number was, but we had if a squared equals b. Now this is a different a than the one we've already talked about, so let's just go ahead and I'm going to rewrite this as if let's see, I'm going to go with alpha, because you're going to be seeing Greek letters eventually. We might as well do it now. If alpha squared equals beta, then alpha equals plus or minus plus or minus the square root of beta. And if you're doing this in your notes, you don't have to write that down, and you probably don't need to do Greek letters anyway. But you will see Greek letters eventually. But, for now, nobody really cares. So, let's go ahead and clear that off. So that means we can use the square root property. That means this entire thing equals the square root, plus or minus the square root of this entire thing. So, on the next line, well, I don't know how long I've been doing this, but I just realized, because I don't look at the clock while I'm making these videos, but I realize I've been here for quite a long time. So that means we have x plus b over 2a equals plus or minus, and this one's going to be a hard one, the square root of b squared minus 4ac all over 4a, wait, what did I do? Okay, missed something, sorry, 4a squared. Okay, let's see if I typed this incorrectly. Yes, looks like I did type it incorrectly. So we have x plus b over 2a equals plus or minus b squared minus 4ac over 4a squared. So, okay, now I'm going to do just a little bit of mathematical hand waving, more or less. I mean, what I'm going to do is I'm going to put this equation, well, let's see, I'll just show it to you. So we'll have plus or minus, and I'm going to take this square root and put it on the individual parts of the fraction. So we have the square root of b squared minus 4ac all over the square root of 4a squared. Okay, so now I'm going to go ahead and take this as 2a. So we have square root of 4a squared is, I wonder if I'm going to have enough room here. I'm going to move a little bit to the right, the scroll bar to the right, so that we can see. This is going to be equal to plus or minus the the fraction of the square root of b squared minus 4ac. Wow, just barely have enough room. All over 2a. Okay, we're getting even closer to the quadratic equation. Now, what I'm going to do, that's sort of mathematical hand-waving, just kind of saying, okay, this will work, is I'm going to take this plus or minus, and I'm going to put it on top here. So that means we're going to say that, and I'm going to go ahead and do it right here. I'm not going to make a new, no, I'm going to go ahead and do it, never mind. So, there's not much room here, but this whole thing then is equal to square root, fraction. In the code that I'm typing this out in, you put fraction first. That's why I keep saying fraction of this. So we have the square root of b squared minus 4ac. But I'm going to go ahead and put the plus or minus in the numerator, all over 2a. And the reason why is because if you have if this entire thing is positive, then this part will be positive. If this entire thing is negative, then this part will be negative. Just trust me, it works out. The reason why it's sort of hand waving is because You don't really know, technically speaking, you don't know that A is positive. In fact, the quadratic equation works when A is negative. So that means that this, technically speaking, should be 2 times the absolute value of A. I don't know if we've actually talked about absolute values. I know we haven't so far in this class, but I don't know if you have before either. But in the end, what happens is it works out because you have plus or minus 2a. It'll cancel out. I'm not sure exactly how to explain it, but hopefully you'll understand that the plus or minus will in effect work. If a is negative, then basically this covers your bases. Let's put it that way. And so since this covers all possible things that could happen, we can put this on top. Okay, so let's go ahead and move on. That was sort of a sidetrack, but let's move on to... So we have... I'm going to rewrite this whole thing just because we kind of lost track of everything. So we have x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. So now let's go ahead and we're very close to getting x by itself, which is what our goal is. So let's go ahead and subtract b over 2a from both sides. Now remember what I said before, that let's see if I can recreate this the way I said it before. So if we have y plus 3 equals, let's say, plus or minus the square root of 5 or something, because we just had that square root of y minus 3 equals 5, so that means we have y plus 3 equals plus or minus square root of 5. Remember what I said before, even if we're subtracting, we usually go ahead and leave the plus or minus on the far right side, so y equals negative 3 plus or minus the square root of 5. So same thing goes over here. So this next line is going to be x equals negative b over 2a. X equals of course, then there's this here, plus or minus. And you know what? I'm going to have to put the plus or minus on the outside of the fraction now. I went to all that trouble to explain why I can do it in the numerator, but for now I'm leaving it on the outside. So square root of b squared minus 4ac all over 2a. So what we have now is minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. These already have like terms, common denominators, so we can go ahead and just add them across. So that means we have that x equals negative b. Now I'm going to go ahead and put the plus or minus back in the top, so we have negative b plus or minus, I need to scroll down. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I talked before about there's parts you should recognize. Obviously at this point you should recognize the entire thing. What we have here is the quadratic formula. So that's how we know that the quadratic formula works. And at the end of a math proof we often put what we call a QED. That's a box. That means we're done. That means this is completely logical. So I'm going to go ahead and put this here because we've accomplished something pretty big. We have proved the quadratic formula. Alright, that concludes this video. I'll be interested to see what the timestamp says at the end because I don't know how long I've been doing this. Turned out to be a lot longer than I thought it would be, but I kind of think this was a fun thing to do. So if you were able to follow this video, and obviously if you did it with scrubbing back and forth to look back at previous parts, that's expected because that's why it's here, so you can do that. So if you were able to follow this, that means you have a pretty good understanding of this, and that's good. But also bear in mind that you're not going to be asked to prove the quadratic formula on a test or a quiz or anything. That's for a higher level math class. But this worked out, so I will see you in the next video.